I'm going to start with a couple of these proofs. And this is the exact one that you have in front of you right now. D is the midpoint of CE, angle BCD and angle FED are right angles. BD is congruent to FT. Prove the triangles are congruent. Now, something should ring little alarm bells in your mind when you see that second given. What might we be looking for just based on that second given, just in the initial glance at this? Because when you get a problem like this, first thing you do is you just kind of look at the picture, you look at what's given, and then you start going on it. But you kind of read over it first. That's our strategy. And as soon as I saw that right angle thing, I started thinking there might be a special possibility here for congruent triangles. What would that be? HL suddenly comes into play, doesn't it? We might have HL. We might not. But HL becomes a possibility, and we need to think about that as a possibility. So, let's do our proof. Step one, remember, givens, picture, and usually that's enough to get us our shortcut. So from the given, we start with our givens, get our congruent parts from our givens, then we go to our pictures, get our congruent parts from our pictures, and then we see if that's enough for a shortcut. So we're given D as the midpoint of CE. That is given. Now, that doesn't give me any congruent parts. Actually, it's going to, but I have to say what the congruent parts are. I don't go to my next given until I get some congruent parts or something going on that's going to help me. So D is the midpoint of CE. What parts are congruent as a result of that statement, Brittany? Yeah. Why? Yeah. Because we used a word here, we use this definition over here to make a conclusion, and we mark it on our picture. Okay? So now I've got some congruent parts, I'll go to my next given. So this given's all used up. I'm going to use this given next. I'm going to jump. I don't have to do them in order. I'm going to use this one because that's like a freebie. I like freebies. BD is congruent to FD. That's given. BD congruent to FD. And now, angle BCD is congruent to angle FED. I'm sorry, it's not congruent to, and angle FED are right angles, excuse me. Sorry. Which means that these are right angles. Now, it didn't say yet that they're congruent. Here's the thing. If I needed to, I could say that they're congruent, because all right angles are congruent. That's one of our theorems. But do I need to say they're congruent here? No, because when I look at this picture, do I have HL at this point? Do I have HL? Well, I've got the congruent hypotenuses, and I've got a corresponding leg. Yeah, I do. So triangle BCD is congruent to triangle FED. HL. And we're done. How could this be different? Well, if I'd have given that these two sides are congruent instead, BC and FE, instead of BD and FD, then I probably would have used this to say that the angles are congruent, use side angle side. But I need congruent angles, not just right angles for that. But for HL, I don't need those right angles to be congruent. For side angle side, I would. But here I don't. But there's my entire proof. Let's look at the next one. And again, right off of your sheet. Given AC is congruent to BC. Okay, mark it in. Step 2, CM bisects angle ACB. That's given. But, that being said, that doesn't give me any congruent parts yet. I have to write down what parts are congruent as a result of that given. Someone else, Brittany, you've already had a chance to answer a couple questions, so let's let someone else have a chance. Oh, well, how about that? We do have a slightly different one. So let's do this one, and then we'll do yours. We'll do this version, and we'll do your version, okay? Let's do this. CM bisects angle ACB. What does that mean? If I'm bisecting an angle, I'm going to get congruent what? Angles. So what angles have to be congruent, Miles?
Angle C or BCM and ACM?
Yeah. Congruent. Reason? What word do we use? Bisect, so definition of bisects. Okay, that's all my givens. I've used up my givens. I've got no more givens. So now I have to turn to my picture. Do I have anything special in my picture? And what are the two key things we look for in a picture? Yeah. It doesn't matter. It could be CM-CM or MC-CM. It doesn't matter. Oh, it's the same segment. The two special things we look for are reflexive, as she just mentioned. What's the other special thing we look for from the picture? Not right angles. We wouldn't give us that. Wouldn't know that in the picture necessarily. Shared side is reflexive. What's the other one we look for? Vertical angles. Pictures don't give us midpoints. Pictures don't give us things like that. Pictures only give us things like reflexive and vertical angles. Shared sides are vertical angles. Those are the only two things we generally get from pictures. Which one do we have here? We have vertical angles or a shared side? Shared side. So CM is congruent to CM, reflexive. Do I have a shortcut? Side angle side I have. And my congruent triangles would be ACM and BCM. Is that what, am I done? No. I'm going beyond. AM is congruent to BM. And what's my reason? CPCTC. Now just a little reminder, folks, on the last test we took using proofs, the last quiz, people are using CPCTC way too early. It is not like the thing that you take that solves all your problems. It's not a happy pill. Okay? CPCTC is after congruent triangles only. Congruent triangles have to be one of our shortcuts, SAS, ASA, whatever. But we can't use CPCTC for congruent triangles. It's only after. Yes. As long as it's after congruent triangles. Okay, I could use it for congruent sides or, because it says parts. Parts could be sides or angles. but only afterwards. Now, your proof is a little different. All right? Instead of giving a bisector, you're given a midpoint of a segment. So you're probably going to wind up with a little bit of a slightly different proof, but I'll leave that to you as part of your homework tonight. Very similar, but a little bit different. Same picture, slightly different result. 58, we're on here. Let's look at the front couple pages here very quickly. We're not going to have time to go over everything. We can still do it. Name the corresponding part. I give you the congruent statement. You just name the corresponding congruent part. You shouldn't even really need to look at the picture. In fact, the picture may confuse you more than anything else. Just look at the statement. Number one, ZYX is congruent to ZHI. So YZ would be congruent to what? Without even looking at the picture. IZ. Yep. And it would have to be segment IZ. That's all you have to do. How about number three? BCD congruent to BTS. So angle C would have to correspond to what? Angle T. And again, we really don't even need the picture. You see how that works? Just use a congruent statement. 5 and 6, write the corresponding order. Please be careful on these. The first one can be any order you want it to be. It doesn't matter. If you want to do UVH or HUV or VHU or even HFG, whatever order you want for a triangle. So let's go HVU. Now, don't get caught up in staring at too much in the picture. Look at the markings to tell you what goes with what. Angle H corresponds to what in the other triangle? Angle H again, yes. H corresponds to itself. That's nice. V corresponds to which angle in the other triangle? F. We can see from the markings. And U, therefore, must correspond to G. Okay? So that's the way that that one is going to work. Let's flip the page over. You are going to have things like name the shortcut again. That's not on here, but that will be on the test. Name the shortcut you're going to use. Just like you've seen before, kind of like mini proofs. Hold on, let me undo this. Okay. If we had something, say, like this, and I gave you this side, this angle, which shortcut are we using? Now remember, it's just like a proof. We don't have to write out the whole proof here, but you still want to have the same thing. What am I given? I'm given an angle and a side. What does the picture give me? The picture is going to give me what in this case? Vertical angles. Mark it in. Okay? So my shortcut is going to be what in this case? Side angle, angle. Actually, we go angle, angle, side. Okay? We always do it in that order. Not side, angle, angle. Angle, angle, side. But it's just like doing the proofs where we go, well, what are we given by the markings, and then what can I conclude from the picture? The biggest problem people have when we get a picture like this one especially is people just making strange conclusions from the picture. They look at the picture and say, oh, I think these are congruent. Really? How? They look congruent? No. Evidence. It's about evidence, not about what it looks like. The only evidence we have here from the picture is the vertical angles. I don't know that's a midpoint. Now, once I know congruent triangles, I can go back and figure out that, yeah, those do have to be congruent parts, but I don't have the evidence until after I know congruent triangles, not before. So what evidence do we have? Remember, from the picture, the only two things we should be getting are vertical angles or reflexive. Number 22, or 21, excuse me. Yeah, let's look at 21. What shortcut are we using? I don't know what happened. I feel like I'm missing like we missed a page when I copied this, but I don't have another page of this. I'm looking at when I looked at that. Ooh, I didn't draw it very well, but you got the picture. This would be more 22. So let's do 22. Get the angle, this side congruent to this side. I'm given a side and an angle, right? The picture gives me what? A shared side. So my shortcut is what? Side, angle, side. Yeah.
How do you know if we could side or angle them first?
I don't until I put them all together and look at the picture. But when I have two sides and an angle, it has to be side, angle, side. That's the only choice I have. Or nothing if it's angle, side, side. And basically, I just start at one side and start working my way as close around as I can. Remember, side, angle, side, the angle is between the sides, just like in the statement. Let's look at 23, isosceles triangles. We just got done with this. You did fairly well with this. What would x be in that case? 65. How about in 25? 76. How'd you come up with 76? Yeah, we had... Right. Because these two have to be the same. So we did 180 minus 28 is 152, and then we have to divide that 152 evenly into those two because it's isosceles. So that's where the 76 comes from. 29, 31, 33, again, very similar to what we just did. 31, let's look at that one real quick. What kind of equation are you going to set up there? How will we set up an equation for 31? What do those angles have to add up to? 180, because they're angles. So we just have to set up 25 plus 135 plus x plus 28 is 180. And then combine the terms. That's 160, 188 plus x equals 180. I subtract the 188, and this is what kind of messes with people's minds a little bit. They go, wait a minute, I can't have negative angles. You're not getting negative angles. You're getting a negative x. You're getting a negative number for x, but that's not the measure of the angle. Yeah, negative 8 plus 28 is just 20, right? So the angle's still positive. So we're okay. We can do that. How about number 33? How are we going to set that one up? This is the exterior angle theorem again, yeah. Yes, exactly correct. And again, we combine like terms. 14x plus 3 is 59. Subtract the 3. 14x equals 56. Divide by 14. X is 4. All right. Classifying the triangle, again, distance formula, midpoint formula. You have to know and be able to execute those formulas. Draw the picture. Take it home and practice. I will not be here tomorrow, but Mrs. Fox will be in here. If you need extra help, she says, please come in and see her before school. She will be here hoping to help people. So please come in and see her for help. Hold on, let me stop. That's interesting. Oh, I got a pen out. Hold on.
Mr. Dorn.
Just a second. Just a second. Where did I put that extra pen? Right. Ah, there. Okay. Well, let me stop the podcast.